All right, everybody, we are back with .NET Conf Focus on Blazor. We have Chris Sainty on the phone call. Chris, pleasure to meet you again.
Javier, how are we?
We're doing great. So you're here to talk to us about routing A through Z. Is that correct?
That's correct, yes.
Perfect. All right, take it away. We're anxious to hear your content.
Cool. Let's get going with some screen sharing. So let me do that and let's get PowerPoint going. Cool. So first of all, let me just say hello and hope. Oh, yeah, nearly forgot. There we go. Cool. So yeah, I hope everyone's really enjoying .NET Conf Focus on Blazor so far. Let me just introduce myself. My name is Chris Sainty, and I'm a lead software engineer, and I'm also a Microsoft MVP. And today we're going to be talking all about routing A to Z in Blazor. So I've divided the session up into kind of two halves. The first half, we're going to be in PowerPoint. We're going to look at all the various parts of routing in Blazor, and then we're going to move over to Visual Studio for the second half and go through some code demos. So we'll crack on because we've got a lot to get through. So let's start off by looking at some real fundamentals. What's the difference between traditional web apps and Blazor apps in terms of routing and navigation? So we're going to load a traditional web app. We're going to type an address into in a browser. We're going to go off to a server. The server is going to return us the initial page for that application, and then our browser is going to render that page for us. Once we've got the application running, we can then click on links within the application. And every time we do this, again, we go off to the server, we get the page back from the server that that the link points to, and then our browser renders that page for us. So that's quite straightforward. Now, the key thing to take away here is that no matter whether we're using HTML pages or whether we're using frameworks like MVC or Razor pages, which create dynamic pages, we're always moving between entire pages, and we're always doing that by going back to the server, downloading a whole page, rendering a whole new page every single time. So how does this differ in Blazor? Well, we load a Blazor app in the same way. We obviously type an address into a browser, we go off to a server, and we're going to get an initial page back from the server for that application, and then our browser renders it. So I'm going to show this through with the Blazor WebAssembly app because I think it's a little bit clearer, and then we'll look at Blazor server as well. So we get that index page and we render our application. But once we're in the application, things become very different. When we click on links in Blazor applications, those navigation events are intercepted by Blazor, and they're funneled through to Blazor's router component. Now, the particular link that we've got here is trying to navigate us to a route of item/2. So Blazor's router is going to use that information, and it's going to look at a routing table that it keeps in memory. It's going to try and find a route that matches, which in this instance would be the second one in the list. Now, the squiggly brackets ID is something called a route parameter. And if you don't recognize that, don't worry, I'm going to cover those a little bit later. But anyway, take my word for it, that's the route that's going to match. Blazor's router then knows that the item details component is the correct component to handle this route. The router is then going to load the item details component and run it. That's going to generate some UI updates. And then Blazor will apply those UI updates, and the view will update for us. Now, the eagle-eyed among you may have noticed that the URL's changed as well. So there's some magic going on there to give us that impression that we've moved to a new page. But really, we've never left the browser. We've stayed inside of that initial index page that we originally downloaded. And this is where single-page applications get their name from. We're operating over a single physical page. So Blazor's dynamically changing the content depending on which route that we're requesting. Now, is there any difference in Blazor server apps? Slightly. When we click on links in Blazor server applications, the navigation event is transmitted over Signal R back to Blazor's router that's running on the server. However, from this point forward, everything pretty much continues as it did before. Blazor's router is going to look in the routing table, it's going to find a route match, and then it's going to load the component that handles that route. Again, it will run the component, calculate UI updates. These will then get transmitted back over the Signal R connection, and then again, our browser will be updated with whatever that new page component looks like. So that was a really high-level view of routing in Blazor. So let's start diving a little bit deeper now, and we'll look at the router component and the various things that it has to handle. So if you've not seen it before, this is the router component in Blazor, and you can find this in the main app component. Now, there's three things that we need to provide the router in order for it to work correctly. The first one is this app assembly, and this is where we can tell the router where to go look to find page components. Now, page components are just regular components that have a page directive at the top of them. Blazor's router is going to scan whatever assembly we give it, and it's going to go and find these page components, and it's going to use them to generate the routing table I was referring to in the earlier slides. The next bit that we need to provide the router is a found template. Now, this is where Blazor is going to load the component, the page component, which handles a route once it's found a match in the routing table. The job of actually rendering that component is handled by the route view component, and it knows which component to load via information contained in the route data object, and that's provided by Blazor's router. That will contain the type of the component that needs to be rendered, along with any parameters that that component needs. The other job that the route view does for us is it provides us the ability to set a default layout for all pages within the application. So by default, that's the main layout component. Now, if you do have a scenario where you have certain pages that you want to use a different layout, that's cool. You can specify a layout on a page directly, and that would overwrite any value set here by the default layout parameter. And then the final piece of the jigsaw is the not found template. So this is what Blazor uses when it can't find a route match in its routing table. The default setup is to use a layout view component. That's a simple component that allows us, again, to specify a layout to use. And then whatever the child content is of that layout view will be displayed within that layout. So by default, it's this p tag with this, sorry, there's nothing in this address message. Now, again, this is all customizable. You can change this. You could change the content of the layout view. You could remove the layout view entirely, and you could put your own component in there. It's completely up to you. So I mentioned a second ago, Blazor goes off and Blazor's router scans the assembly we give it to discover page components. But how does it actually discover these page components? How does it know what they are and identify them? So in order to make a regular component into a page component, we use the page directive, which is, you can see it in this top left of the slide here. The second part of the page directive is the route template that this particular component will handle. So this component here would be loaded whenever we went to the items route. But Blazor's router doesn't actually look for these page directives themselves. It actually looks for something else. So what does it look for? Well, all Blazor components are compiled into classes. So this particular component would compile down to a class that looks something like this. And as part of that process, the page directive is transformed into a route attribute. And then the route template that we've specified in the page directive is also passed into that route attribute. And it's these route attributes that Blazor's router is looking for. So it scans that assembly we give it. It looks for any components that are decorated with this route attribute. And then it goes off and it stores them in something called a route entry. And the route table just contains an array of these route entries. So the route entry is made up of two pieces. It's the template that component handles, and then the handler, which is the type of the component. There are a couple of other bits on a route entry, but they're really not relevant for us. We won't worry about those too much, but that's the key pieces of information. So the next bit that we're going to talk about, intercepting navigation events. How does Blazor's router actually know when we click on links, and how does it get the information about the route that we're trying to get to? So we're going to look at an example here. We're going to try and navigate to this item/to route. So how does this work? Well, when we click on this link, then the link click event is going to get intercepted by Blazor's event delegator. Now, Blazor's event delegator handles all of the eventing in Blazor applications, but it does have a special use case for navigation clicks. So there is a navigation manager which sits in the JavaScript part of Blazor, and that registers a callback with the event delegator specifically for link click events. So when we click the above link, the event delegator is going to intercept that click event, and then it's going to invoke that callback on the navigation manager. The navigation manager is then going to go off and it's going to do some checks. So the first thing it's going to do is going to check to see if interception is enabled. Now, this is enabled by Blazor's router when it boots up, and it's quite an important check because if the router is not there, it's failed to boot, whatever, then the navigation manager is not going to continue to handle the event because there's nothing further downstream to deal with it. The next check it does is for modifier keys. So this is where we hold down Control when we click a link in order to open it in a new tab or a new window. If the users chose to do that, we don't want to interfere with that. We want to allow that to open in a new tab or a new window. In a similar vein, there's a check for a target attribute. So a target attribute is a way of specifying programmatically that a link should open in a different location, be that a new window or a new tab. So again, if one of those is present, then the navigation manager is not going to handle the event anymore. There is a slight caveat with that one though. If the value of the target attribute is _self, then the navigation manager will continue to handle it, because _self effectively means open where you are. And then the final check is to see whether the route that we're requesting is within the scope of the base URI. Now, the base URI, if you're unsure, is set in either the index.html page of a Blazor web application or the _host.cshtml in a Blazor server application. Now, usually this is just set to a / and it's this tag here. And this effectively means that the application is running at the root. So if we had a Blazor app running at this URL, contusostore.com, we would just have the base tag set to /, which means the Blazor app is running at the root. So the router would handle all routing or all navigation events within the app. However, if we're hosting a Blazor app as a sub application of an existing app, so say for example we had our Blazor app running at contusostore.com/Blazor, well, we wouldn't want our router to interfere with any routes that didn't begin with Blazor. So we can set the base tag here to be /Blazor, and now the router will check that as part of this process. So if the route that we're trying to get to does not start with Blazor, then the router is going to leave the event alone, and it's going to assume we're trying to navigate away from the application. So once all these checks happen, if any of them fail for whatever reason, then the event is allowed to continue as normal. So that will execute down its normal path. However, if all of these checks pass and the navigation manager feels it should deal with them, it's going to do two further things. It's going to update the browser history in the address bar. So I touched on this in the earlier slides. This gives us that feeling of navigation, okay? And it means that things like the forward and back buttons on the browser are going to work and things like that. And then the next thing it does is it calls a function called notify location changed. Now this function essentially just fires a callback over to C#. Now, depending on whether we're using Blazor WebAssembly or Blazor Server, this goes two ways. If we're using Blazor Server, this goes back over the Signal R connection and enters C# that way. And if we're using Blazor WebAssembly, then we use some JavaScript interop to call back over and go back into the C# world that way. So once we do this, we're going to hit the navigation manager that's in the C# part of Blazor. Now, this is something you may be familiar with if you've done any Blazor development. This is the navigation manager you may have injected into your components to use the URI property or hook onto its location changed event and things like this. And this pretty much is what this location change callback is going to do. It's first going to Oh God, sorry, hold on. Let me just get back to where I was. My application's gone a bit nuts there. Ooh. There we go. Skip through here. Cool. So there we go. So what's going to happen is the first thing it's going to do is update the URI property on the navigation manager to wherever we're trying to get to. So in this case, it would be items/2. And then it's going to raise a location changed event on the navigation manager. And this is what the router is listening for. So the router is then going to take the information, it's going to check the URI property on the navigation manager, and it's going to check that against its routing table. If it finds a match, it's then going to load the component that handles that route. So that's how we go from clicking a link to the router actually loading the correct page component. So the final bit I'm going to talk to you about in slides is route matching. So how does the actual route matching process happen? So say we're trying to get to this route. So we're going to go to tech/cameras. So we know that the Blazor's router is going to look through route entries in order to find a match. And up till now, I've always sort of said the template is this this full string, this /tech/cameras. But actually, the route entry object doesn't store them this way. It splits them on the slashes into segments. So this particular route would become tech and cameras, okay, as two separate segments. The router does a similar thing to the route that we're trying to get to. It splits that down into segments as well, so tech and cameras. And then it just does some checks to see if everything matches. So the first thing is Dear, oh dear. Sorry, I do apologize. The first thing it does is a segment count match. So here we can see we've got 2 segments in the template on the left, and we've got 2 in our requested route on the right. So that's a segment match to start off with. And then the next thing it does is do a segment by segment check. So these are just string comparisons because all segments are treated as strings. So tech and tech, that's a match. So that's cool. And then cameras and cameras, that's a match. So in this instance, the router would consider this a match across all segments, and therefore the route matched, and it would now try and load the camera list component to handle that route. Now, the other thing about route matching is where route parameters are involved. So I've touched on those a little bit. I touched on those a little bit earlier. So here we're trying to navigate to items/2. So in this instance, the template would look like this, but as we know, it's stored in segments. So that would break down into 2 segments, items and ID. Oh my good Lord, sorry. So there we go. So that would break down into 2 bits. So again, we do the same thing. We do a segment count match here, and then we do a segment by segment match. So we're doing a string comparison here, which is items and items. So that would match. And then the next thing is this squiggly brackets ID, which is a route parameter. Now here, the router is just going to push whatever is in the second segment of the requested route into that route parameter. So in this instance, this would all match. So again, this would be another match, the route would match, and it would load the view item component in order to handle that. I'm going to talk to you a bit more about how route parameters work in the demos, because I think it's a bit clearer there, but I just wanted to touch on this now in the slides. So that is it now in the slides, and I apologize for my computer going a bit nuts doing that. So I'm just going to come out of PowerPoint now, and I'm going to jump over to Visual Studio, and we're going to go through some demos. So first of all, I've got a solution here, and I've just got a brand new Blazor server application. It could be Blazor WebAssembly. There's nothing specific I'm doing here to one hosting model or the other. And the other thing I've got is a Razor class library. Now, I've set up a project dependency from my Blazor server application to the Razor class library. And the first thing I want to talk to you about is how you can load page components that aren't actually in your Blazor application directly. So here's the app component, and this contains Blazor's router. We talked about this earlier. And we can see that we have the app assembly, and we're passing in our Blazor applications assembly as a value there. So how can we load a page component from this Razor class library? Well, the first thing is I'm going to repurpose this component1.razor. I'm going to make it into a page component, okay? So I'm going to do that by using the page directive. And we're going to get a root template of RCL, okay? So that's all I need to do to make this a page component. So now I've done that, how can I tell the router where to find it? Well, I can use the additional assemblies parameter on the router, and this just takes an array of assemblies, so I can pass in as many as I want. So let me just quickly type this out, and we can do this the same way as we did above. And I can say Razor class library.component1, and I can say scan that assembly. Okay, so that's all I need to do. Blazor's router is now going to scan the app assembly we've provided along with whatever we've put in this additional assemblies parameter. Now, to make life a little easier, I'm going to open the nav menu component. I'm going to add a link to our new page just so we can navigate to it a bit easier. So I'm going to put the route in here, which is RCL. And I'm just going to update this, the name for that link there. So quickly while I'm here, I'm using the navlink component to do this. This is a great little helper component that comes out of the box with Blazor. It just generates a normal anchor tag. But what will happen is when we're on the RCL route, it's going to apply an active class to that anchor tag. So this is great. You can then style active links, which is can be really useful. So we've got all that in there. So I'm just going to save that. Now, if I jump over to the browser and do a refresh. Now you can see I've got this our new link on the side here, this RCL page, and when I click on it, you can see the route has updated in the address bar here. We've moved to the RCL route, and we can see we've now got that component loading from the Razor class library. So that is how we can load Blazor pages from external libraries, which is quite cool. So the next thing we're going to talk about is root parameters and root constraints. So we talked about those a second ago. So we're going to have a loot at them in a bit more detail. So I'm going to repurpose the counter page for this. So if you've not seen the counter page before, it's just a simple page where I can click and increment a counter. But what happens if we want to increment the counter from a different starting value instead of 0? How can we do that? Well, what I'm going to do is I'm going to make some modifications. I'm going to add an additional page directive. I'm going to give it a template of counter / I'm going to put these squiggly brackets in and I'll say starting count. So this is how we define a root parameter. We use these curly braces and then we give it a name. But how can I access what's in there? How can I use this in my component? Well, I'm going to remove this private field. I'm going to create a parameter on the component. And I'm going to call that starting count. So that matches the same name as I've given my root parameter. And then what's going to happen here is when Blazor's router does the match, it's going to pass whatever value is in that segment of the root into that property that I've just defined, that that component parameter. So I need to make a couple of changes here just to make everything work. So let's put starting count there and we'll do the same there and we'll save that. Cool. Now that should be all we need to do. So let me just go over to my browser and I'll do refresh. And if I click on the counter page, you can see it started from 0 as it did before. But now I should be able to go /10. Oh, my keyboard is not happy today. There we go. /10, hit enter. Oh, but now I've got an exception. So this is odd. So what does this say? We're unable to cast object of type string to type system int 32. So let's go back to the code and try and understand what's gone wrong here. Now, you may recall when I was talking about root matching, I said all segments are treated as strings. And that's exactly what's happened here. The router is treated with the value in this segment as a string. However, I've typed my component parameter as an int because I want to work with it as an int within my component. So Blazor's router doesn't know this, so it's tried to pass it in as a string, and that's why we've got that exception. So I need to tell the router that whatever is in this segment of the root needs to be castable to an int, and I can do that using something called a root constraint. So if I do :int like this, now I'm saying to Blazor's router, whatever value is in there must be convertible to an int, and if it's not, then this is not going to be a root match. So by doing that, if I hit save, and I'll jump back over and I will just do a refresh, and now we've got everything working as we wanted. We've got our current count starting at 10 and it's working as it did before. I can change this now to 101 and hit enter, and we can see it's starting from that current count again. So that's all good. And just to make the point even more, if I now change this final bit, if I put foo in here, for example, and hit enter, you can now see that we're hitting Blazor's not found template because that is no longer a root match because foo will not, we cannot cast foo to an integer. Cool. So that's a quick whiz through root parameters and root constraints. So the next thing I want to talk about is programmatic navigation. So that's quite an important thing in most applications. There's going to be plenty of occasions where you're going to want to navigate to different places programmatically. So how can we do that? We're going to leave the counter component as it was. And we're going to move to the index page. And we're going to make some modifications here. So I'm going to inject... can't type today. I'm going to inject the navigation manager. Like so. And then what I'm going to do here is I'm going to paste some code because it's just a little quicker. And then we're going to walk through it. So what I've done is I've added a input to the index page and I've bound it to this private field, which is an integer, which is going to be our starting count. So we're going to be able to type a value into this input. And then when we click this button down here, we're going to use the navigation manager and we're going to use its navigate to method to programmatically navigate to our counter component with that particular starting count that we want it to use. Okay, so it's very, very simple to do this in Blazor. So that is all we do. So if we save that off and then we go back to our browser and I do a refresh, so you can see here is our input and our button. So if I now type in 12, for example, and hit go to counter, then you can see the current count is now starting at 12. I can go back, I can change that again to something else. and I can hit go to counter, and again, that is all working. Okay, so that's a really really quick and easy one again. So that's programmatic navigation in Blazor. So the last thing I'm going to cover, and the last demo I've got for you, is to how we deal with query strings in Blazor applications. So in order to do this, I've had to install a NuGet package. Okay, so I'm just going to show you that first. So in here, if I just zoom in, we'll go over it and up that. So this Microsoft ASP.NET Core Web Utilities. Okay, so that's got some helper methods that's going to allow us to deal with query strings really easily. Because as it turns out, Blazor doesn't actually do anything with query strings by default. In fact, the root will actively ignore query strings. So what we're going to do now is we're going to try and navigate to our counter component, and we're going to try and pass the starting count as a query string instead. So in order to do that, I'm going to make a quick change to this piece. Oh dear. Like this. And I'm going to say starting count like this. So I've specified now a query string of starting count, and we're going to set the value to whatever we type into the input text box. So that's actually all we need to do on the index page. We're going to leave that alone. So the rest of our modifications are going to be in the counter page. So what I'm going to do is I'm going to inject the navigation manager again, as we did in the index page. And then I'm going to, again, copy in some code. So I'm just going to bring that on a new line just to make it a bit easier. So what we're going to do here. So first of all, I've overridden the onInitialized lifecycle method of the counter component. So this is going to fire when the component is first run. The next thing that we're going to do is we're going to get the current URI, and we're going to get that as a actual URI object. So you can see here the type is a system.uri object. And in order to do that, we're going to use the navigation manager, and we're going to use its toAbsolute_URI method. We're going to, again, use the navigation manager to get the current URI as a string, because we need to pass the, whatever URI we're trying to get as a string into that absolute URI method. So that's going to give us this URI object. Then we've just got a little if statement, and we're going to use this query helpers class, which comes from that web utilities library. And then it's got a pass query method, and here we pass in the query string that we want to operate over. And this is where using that URI object becomes really useful, because we can just say URI.query, and it's going to separate that query string out from the URI for us. So that's really useful. Then we're going to call the try_get_value method. And in there, we're going to say, right, we want to try and get the value for the starting count query string. And then whatever value that has, we're going to want to output it to this underscore starting count variable. If all that succeeds and we get a value come out, then we're going to hit this bit of code here. And basically what we're doing is we're going to assign the value of starting count to that starting count parameter we created earlier. But before we do that, we're going to convert it to an integer, because it does come out as a string. Now, it's probably worth doing something a little bit more robust in a real application than this, because obviously if this couldn't be cast to an integer, this would throw an exception in, and things would burn. It would be not good. So definitely do something a bit more robust. So that should be it. So if I save this off now and we go back to our browser, if I refresh, if we head to the home component and I type in 12, for example, and hit go to counter, everything has worked. So we can see here we're navigating to our counter component, and we've got our query string here. So starting count equals 12, and we can see that our counter has correctly been initialized with a starting count of 12. So we can still click and increment. So that's all working as it did before. So it's all good. Doesn't look like we've broken anything. So I appreciate that was quite a whistle stop. There's definitely a lot more we could talk about with routing, but that is basically it from me. So hopefully we've got some time left for some questions, and yeah.
We do have some questions, actually.
Hey, Chris. Yeah, we do have some questions here. Beth, did you put one up?
Yeah, here
for
we
me?
go. How about this one?
Hey, Chris, you want to share your camera and stop sharing your screen so people can see you?
Yes, yes.
Sweet.
Yeah, let me just do it.
Perfect. All right.
Ooh.
So we got a question from asking when to use navlink and when to use a href. Is there any major differences?
So it depends what you're after. So the as I mentioned, the navlink component, all it really does for you is it applies that active class when you're on that page that link is for. So you would have seen through the demos there that the menu on the left hand side, every time I clicked on a link and I moved to that route, the background changed to a slightly different color, and that was because of some styling that's applied in the default template. So if you want to have that kind of stuff happen automatically, then yes, use the navlink component. But ultimately, that's pretty much the majority of what it's doing for you. You can just use a normal href otherwise. So if you're not interested in that custom styling.
Perfect. Beth has another question up here. Let's take a look at it. Chris, how do you deal with fragments such as /help pages, /FAQ, hashtag? How do I sign up? So how do you build that up in Blazor?
Okay, so is that in terms of actually routing to a certain place on a page?
Yes, exactly. Yeah, like for example, I want to go to specifically the midsection where I'm listing the speaker or whatever chunk of code I may have.
Yeah, got you. Yeah, so I'll be honest, I've had this question quite a few times from various people. That I'll be honest, at the moment, it's not overly easy to do. You'd have to use JavaScript interop to do it. So there's nothing you can do in Blazor out of the box. You would have to you'd have to create some JavaScript, and I believe it's something like you'd use scroll to on an element. But yeah, it would be a JavaScript interop in order to do that.
Perfect. So it's funny because we actually do have a great JavaScript interop session later on the day by Javier Cavarro Nelson, who is a software engineer on the Blazor team. So please stick around for that and we can find out more about it. Beth, we have one more question. Perfect. Oh, it's over here. Can we have sample of implementing direct URL, something like it works out of the box in MVC?
Direct URLs?
Redirect.
Oh, sorry. It was redirect URL.
Redirect URL.
I misspoke.
Oh, redirect. Oh, okay. Yeah, you can actually do that quite. You can probably do that quite easily in Blazor in terms of a component. So you could actually have a component at the route that you want to redirect from, and you could override its uninitialized, inject the navigation manager, and you could just immediately redirect to wherever you want to go. So you could handle it that way. It's not the most cleanest way of doing it, but you could do it that way right now.
Perfect. Thank you so much. Well, Chris, thank you so much for taking the time out of your day. Again, we have a lot of great speakers. Most of them are from outside of the studio just because of logistics and trying to get people in and out. So Chris, thank you for calling all the way from the UK.
My pleasure. Thank you for having me.
Perfect. So what we're going to do here is Beth Massey actually has several announcements to give to us with regards to Blazor.
Several.